Welcome to the DIY Honda Garage channel. The DTC P006E indicates a malfunction in the turbocharger power supply circuit, specifically within the wastegate control actuator system of the 2022 and newer Honda Civic. This trouble code is set when the powertrain control module, PCM, registers an abnormal voltage in the power supply circuit, meaning that the voltage drops below a specified threshold. The wastegate control actuator is essential for regulating the turbocharger's boost pressure, enhancing engine performance and efficiency. If the power supply is faulty, it can affect the vehicle's acceleration and overall performance. Proper troubleshooting and repair are vital to restore functionality to the turbocharger and prevent further performance issues. This presentation will walk through the diagnostic steps to rectify the P006E DTC, aiming to return your Honda Civic to optimal operation. DTC P006E signifies an issue with the turbocharger wastegate control actuator, primarily focused on its power supply circuit. The PCM, or powertrain control module, monitors this circuit continuously to ensure it delivers adequate voltage. When it detects a voltage lower than a specified value, it registers DTC P006E. The wastegate control actuator is crucial as it regulates boost pressure by controlling the flow of exhaust gases flowing through the turbine. The actuator is located near the turbocharger, integrated with the turbo system's plumbing components. A malfunction in this component can lead to suboptimal engine performance or increased emissions, making it critical for vehicle operation. Several potential causes could lead to the triggering of DTC P006E. An open wire in the power supply circuit could interrupt the flow of electricity to the turbocharger wastegate control actuator, impeding its function. This can occur due to wear, corrosion, or accidental disconnection in the wiring. A shorted wire, another significant issue, occurs when the circuit contacts another component or ground, leading to improper voltage delivery. It is also possible for the PCM itself to be malfunctioning, misinterpreting the signals from the actuator, or failing to control it correctly. Each of these factors must be evaluated thoroughly to determine the root cause of the malfunction. When DTC P006E is active, several symptoms become apparent, impacting the driving experience. The most immediate is the illumination of the check engine light on the dashboard, signaling that the PCM has identified a malfunction in the vehicle system. Drivers may also experience decreased engine performance, where the vehicle may not accelerate as expected, leading to a frustrating driving situation. Another observable symptom is a poor acceleration response, where pressing the accelerator does not result in proportional power increase due to potential turbocharger issues. These symptoms collectively indicate that the turbocharger system requires prompt attention and diagnostics. The first troubleshooting step for DTC P006E is to start the vehicle in the on mode without turning the engine on. This allows the PCM to run diagnostic checks and provide real-time data regarding the turbocharger circuit. Verify that the voltage readings meet specification. If the supply voltage to the turbocharger wastegate control actuator is below the required level, this confirms that an issue exists. Next, inspect the wiring connections in the circuit for any signs of damage, disconnection, or corrosion that could cause voltage drops. Attention to detail in this initial step lays the groundwork for resolving any further complications. In this second step, the PGM-FI subrelay is disconnected, which is essential for isolating the circuit issue. With the subrelay detached, inspect the PCM connector A, specifically the female terminals of the 50P connector. A thorough visual examination is recommended to identify any possible damage or oxidation, which may affect the connection quality. Next, proceed with an open wire inspection by measuring the resistance of the +B VB act leading to the wastegate control actuator. If the reading shows resistance less than 1 ohm, the circuit is intact. However, a higher resistance indicates a wiring issue needing further investigation. The third troubleshooting step involves checking for shorted wires in the circuit, which can compromise the voltage supply to the turbocharger system. Before proceeding, it's necessary to disconnect relevant components, including the fan control relay and the AC condenser fan relay, to ensure no parasitic loads affect the circuit. Once all components are disconnected, measure the resistance across the +B VBACT at the female terminals of the PGM-FI subrelay. A normal condition indicates no short to ground. If resistance is low, there is a short circuit that requires tracing to the source. Each electrical path must be confirmed for integrity to rectify the voltage drop issue. If previous inspections indicate normal conditions and there is still an issue, the fourth step requires examining the PCM for faults. The PCM is the brain of the vehicle's engine management system, controlling various components including the turbocharger wastegate actuator. To perform this inspection, check for internal diagnostic trouble codes related to the PCM itself to determine if it has failed to interpret or transmit the required signals effectively. If the PCM is not operating as designed, it may need to be replaced to restore full functionality to the turbocharger power supply circuit. This intensive investigation ensures the reliability of repairs and prevents future occurrences. After completing the necessary repairs, the final verification step involves clearing the DTC and conducting a test drive to confirm that the issue has been resolved. This process allows the PCM to refresh its memory and rerun diagnostics to see if the DTC reappears. Monitoring performance metrics is crucial. Ensure that the vehicle accelerates smoothly and that no warning lights activate. Make sure to experimentally check the turbocharger operation, which includes reviewing the wastegate's response to engine load. A steady operational performance post-repair validates that the troubleshooting and repair process was successful. Conducting preventive maintenance can significantly reduce the chances of encountering DTC P006E in the future. Regularly inspecting electrical components involved in the turbocharger system ensures any wear and tear is addressed promptly. Keeping connections clean is vital, since corrosion can impede performance and lead to voltage drops over time. Furthermore, staying informed about any manufacturer updates or recalls related to the turbocharger system can help mitigate problems before they arise. By implementing a proactive maintenance schedule, you can maintain the efficiency and reliability of your Honda Civics turbocharger system, enhancing the longevity of the vehicle. In conclusion, understanding DTC P006E and its implications for the Honda Civic is crucial for maintaining optimal vehicle performance. Following the detailed troubleshooting steps ensures a systematic approach to diagnosing and fixing the issue. Each step taken, from inspecting wiring to verifying PCM operation, contributes to an overall better performance and reliability of the turbocharger system. Continuous learning about preventive maintenance strategies further prepares vehicle owners for potential issues, minimizing downtime and repair costs. Ultimately, timely diagnosis and effective resolution of DTC P006E can result in a more enjoyable and efficient driving experience. Please like and subscribe to the channel. See you next time.